Hi Bobcats, this is Miss Lee, and today's video lesson is on solving one-step equations with models. Make sure as you watch the video that you're taking good notes. Okay, if a scale is balanced, it means that it has equal amounts on both sides of the scale. If one side of the scale has more, then it's out of balance, but as long as the amounts are equal, then your scale is balanced. When you hear the terms or the words solve this equation or to solve an equation, it means you want to find the value of the variable. What does x equal? What does t equal? And to find the value of the variable, you need to isolate the variable. Isolate means to get it alone, get it by itself. So whatever the variable is, you need to get it by itself on one side of the equal sign in your equation. So here we have the model x plus 6 equals -8. So we model, or the models that we use for our equations, our algebraic equations, are algebra tiles. We've already used algebra tiles before. We're familiar with them. So here we go. Let's model the equation. Here's our x. There's only one x, so we only need one algebra tile. One x tile, and it is positive. And then we have 6 positive unit tiles. So here are 6 positive unit tiles. Equals, the equal sign divides our equation up into a left side and a right side, and it equals 8 negative tiles. And they represent the negative unit tiles as being shaded gray. So these are negatives. You could put the negative symbols in there or not, it's up to you. But this is our equation being modeled. The two sides are equal. They are in balance like a scale is in balance. Now we need to isolate the x tile. We need to get it by itself. That means somehow we need to remove these 6 positive unit tiles so that we're only left with the x tile. To isolate the variable, we perform inverse operations. Inverse means the opposite. Okay, so what is the inverse or opposite of addition? Subtraction. What's the inverse or opposite of division? Multiplication. Okay, so if we have 6 positive unit tiles here, what is the opposite of 6 positive unit tiles? 6 negative unit tiles. So to isolate our x tile, to get it by itself, we can add 6 negative unit tiles. And if you'll recall from when we did our integers unit, a positive and a negative make a 0 pair, right? So if we have 6 positives and we add 6 negatives to that, that means it's going to cancel out. It's going to 0 out. And it leaves us our x tile by itself. Our x tile is now isolated. And that's what we want. But don't forget, the scale has to stay balanced. So what you do to one side of the equation, you have to do the same thing to the other side. So if we added 6 negative unit tiles on the left side, then we have to add 6 negative unit tiles on the right side. Now we're in balance. And now we can solve. The x is by itself, so we're going to have x, bring down your equal sign, and count all of your negative tiles. There's 2, 4, 6, 8. Add 2 more makes 10, 12, 14. So x equals a -14. That would be your answer. That wasn't so bad, was it? Let's do another example. Okay, so here we go. I've actually put the models here for you, positive and negative x tiles, positive and negative unit tiles. So we're going to start. This is called an algebra mat, and there's usually a line underneath, or a line that represents your equal sign that splits your equation up into a left side and a right side. So over here on the left side, we need to model one x tile. It is a positive. So your x tiles can be vertical, like mine, or you could turn it horizontal. It's up to what you prefer. And then I have 3 negative unit tiles. So the unit tiles are the little squares, 3 of them, and they are negative. So here's our x minus 3. Then on the right side of the equal sign, we need -5. So that's going to be represented with 5 negative unit tiles. Make sure you're putting your sign on your tiles. And now we're ready to solve. So we need to isolate the x. Here's our x over here. We want it to be by itself. So we want to end up with just an x tile equals something. So we have to somehow remove these 3 negatives. And we learn to do that, you do the inverse or the opposite. So the inverse or opposite of 3 negative units would be 3 positive units. So the negatives and the positives zero out, and they leave you your x tile. But remember, what you do to one side of the equation, you have to do the exact same thing to the other side of the equation. So since we added 3 positive unit tiles on the left side, we need to add 3 positive unit tiles on the right. There's the 3 positives. Now we have both positives and negatives over here on the right side, so we have to remove our 0 pairs. And there are 3 of them. What are we left with? 2 negative unit tiles. So x equals a -2. Now you can check your answer by substituting your solution for x, your value for x, into the equation to see if it's true. So I'm going to substitute a -2 for x, so it's going to be a -2 minus 3 equals a -5. So now I'm going to combine. The signs are the same. You add them and you keep the same sign. -5, does that equal a -5? It does. We solved it correctly. So pause the video if you need to take a moment to go back and look at this to see how we modeled the solution. If you need to rewind it and rewatch it again, go ahead and do so. Okay, next one. We're going to use models to solve. This time our equation is 3x equals 9. So we're not adding 3 to the x. We want 3 x's. Okay, so let's draw 3 x's. They are positive. That's the left side of the equal sign. On the right side, we need 9 unit tiles. And they are positive as well. So make sure you put the signs on each one. Okay, so I know that 3 x's equal 9, but I want to know how much does just 1 x equal? Well, I need to do the opposite, right? The opposite of multiplication is division. So I'm going to take these 9 and I'm going to make 3 groups, 3 equal groups, because I have 3 x's. So here's one group, here's a second group, and here's a third group. And each group has the same amount. So this first group will go to the first x. The second group will go to the second x tile, and the last one will go to the last one. But each x tile equals 3 positive units. So x is going to equal 3. That is our solution. We can check it by going back in here and saying, let's substitute 3 for x. So 3 times x, which we're substituting 3, should equal 9. Well, 3 times 3 does equal 9, so we solved it correctly. So go ahead and pause the video, model and solve the next equation, 2x equals -8, then come back and check your answer. Okay, let's see how you did. We have our 2 x's equal 8 negative unit tiles. Okay, the opposite or inverse operation of multiplication is division, so we want to take our 8 negatives and we want to divide them into 2 equal groups. So each group got -4. That means this x tile gets 4 negatives. The second x tile gets 4 negatives. So our answer would be that 1x, or x, equals -4. We can go substitute it in for x in our equation to check. 2 times a -4 should equal a -8. Does it? Yes, it does. We solved it correctly. Good job. Okay, now we have a little bit different problem here. Let's look at what this model is showing us. You'll see it shows 1x, and what is being done to the x tile? It's being divided into 2 parts, isn't it? So the equation would be x divided by 2 equals, and what does it equal? 2, 4, 6, 8 positives. X divided by 2 equals 8. But when we solve this, we're not looking for the value of half of the x. We're looking for the value of 1 whole x, right? We want to know, what does 1 whole x equal? So what you're going to do, this 8 right here represents half of x. So if this half of x is 8, that means this half of x is also 8. So what does the total x equal? Well, 8 plus 8, which is 16. X equals 16. Check your answer, plug it back into our equation. Substitute 16 for x. So instead of x divided by 2, we're going to do 16 divided by 2. And does that equal 8? Well, 16 divided by 2 does in fact equal 8. Okay, let's go ahead and model this next one. This next one, what is being done to x? It's being cut into 3 parts, isn't it? So let's cut it into 3 parts. Equals, and then over here on the right side of our equation, we have 4 negative units. Okay, so x divided by 3, or 1/3 of x, equals this negative 4. So if this is negative 4, if this third is negative 4, that means this third is a negative 4, and the last third is also a negative 4. So 1 total x equals negative 4 plus negative 4 plus negative 4, which is a negative 12. Check your answer. Substitute negative 12 for x. Negative 12 divided by 3 should equal a negative 4. Well, a negative divided by a positive is a negative, and 12 divided by 3 is 4. So negative 4 is correct. We solved it correctly. Okay, good job, Bobcats.